Welcome back, and now we're going to put our matrix operation skills to the test. So we have A and B is stated, and we want to find this matrix X, right? Well, okay, so I know normally if this was an equation, I want to solve for X. Well, why can't I do that here? So 2X plus A is equal to B. Well, in a normal equation, I would subtract A, okay? I know how to subtract matrices, right? So this is just 2X is equal to B minus A. And then normally I would want to divide by 2, so that would be divided by 2. Okay, that's the same as 1/2 times B minus A. So this is perfectly fine. All I have to do is do matrix subtraction, which I know how to do, and then scalar multiply the result by 1/2. Okay, so I think I can do that. And then, so B minus A, I would get the matrix, so I have to do 2 minus 4 is minus 2. Negative 1 minus a negative 3 is positive 2. 6 minus 1 is 5. And then 5 minus 11 is minus 6. Okay, and then I have to do 1/2 of this, so I get the matrix negative 1, 1, 5 halves, and minus 3. Okay, and that would be the value of X. Okay, not too terrible, but again, it would be useful, at least for me, to take any equation that you have like this and solve for X first. All right, next example. I really like this one. This is kind of a little bit based in geometry. So we have a triangle with vertices of that, okay? It says draw this triangle. Okay, I need to draw this, so let's do this. Okay, so we're mostly in the first quadrant. 1, 2, 3, 4, 5, 6. 1, 2, 3. And so I have this triangle. Here's a point, and then here's a point, and then I have 3, 3. Okay, so my triangle looks like this. All right, and then I want to represent the vertices of the matrix as the first row. Okay, whoa, okay, so I have a matrix. There's going to be 2 rows because it's talking about X and Y, okay, and it says in the first row use the X coordinates, so that would be 1, 6, and 3, and then in the second row use the Y coordinates, so 0, 0, and 3. Okay, is there anything else? Nope, that's it. Okay, so this is part A. Part B, it says, suppose we wish to shift, and this is a typo, that should say the triangle, not the matrix, the triangle. That doesn't make sense to shift a matrix. Triangle. Down 3 units and 2 units to the right. Okay, so use matrix addition to determine the new coordinates, and then verify the result graphically. Okay, so what I want to do in part B now is I want to, it says matrix addition, so if I am adding things, I have to make sure that the result is a 2 by 3 as well. I want to shift it down 3 units. So, okay, if the first row is the X coordinates and the second row is the Y coordinates, if it's going down 3, that means the Y coordinates all need to be minus 3. Okay, because I'm taking each of the Y coordinates and shifting them down. Okay, that makes sense. Now 2 units to the right, okay, so left and right is the X, so I want to take that and add 2 to make it go further to the right. Okay, so this should be the matrix that I need to add. And then if I find A plus B, the result is, let's see, so 3 minus 3, then we have 8 minus 3, and then 5, 5 and 0. Okay, so then if I just plot these points, so let's see, I need to extend my graph, so that was 6, 7, 8, and I need to go down 3 as well. 1, 2, 3. Okay, so then we would have our new points as 3 minus 3. Oops, that's 4 minus 3. 3 minus 3. 8 minus 3. And then 5, 0. 5, 0. Okay. And so if I take now and look at this, this point went 2 to the right and down 3, which is exactly the moves that I need to make. So it makes sense. Okay, so there we go. All right. In part C, it says find the products of that and that. What effect does it have on the graph? Okay. So if I look at those matrix products, okay, I'm going to do this in purple. So I take -1, 0, 0, 1, and then I multiply by my matrix A, 1, 0, 6, 0, 3, 3, okay. First of all, is this defined? This is a 2 by 2. This is a 2 by 3. Yes, that is going to be okay. And if I get this, I'll let you pause the video and get the result. Okay. What should have happened is the following. -1, -6, -3, 0, 0, 3. Okay. And so if you think about this and what happens here, so I need x is going out to -6. 1, 2, 3, 4, 5, 6. Okay, what happened was this point went over here, 6 went to -6, and then we had a point at 3, 3, so that went to -3, 3. So something like this. My diagram is not to scale, but here we go. So we went kind of like there, there, and there. This was a vertical reflection. Actually, I'm sorry, this is horizontal. I'm sorry, you flip it over a vertical line, but it's actually reflecting horizontally. It's flipping left and right. Reflection. Okay, so that -1 is kind of a dead giveaway. Okay, we switch the x-coordinates, meaning you switch it horizontally. So then I'm not going to do this one for time, but notice here we have a -1 in the x and a -1 in the y. So this one, you can double check it, but your matrix that you get at the end should effectively be -a because you are reflecting it both horizontally and vertically. Okay, so this should just be -a. But you can go ahead and double check that on your own. Okay, so just some fun applications with our matrix operations and thinking about things in a different way and having fun too.